Lesson 7.7 is about operations on functions, specifically about operations on our polynomial functions that we've been looking at. So some of the basic arithmetic functions or operations that we can look at are like the sum, difference, product, and quotient. Again, so sum is just plus, difference is when you just take minus, product is when you take something times another, so we use that dot usually, quotient is divided by something. So the definition would be if we had f plus g of x, we would take our f of x plus our g of x. So examples, if our f of x equals x plus 2 and our g of x equals 3x, then f of x plus g of x, or f plus g of x, would be our x plus 2, that f of x, plus our 3x, our g of x. So in total, it would be 4x plus 2. Moving right along here, we're looking at a difference. So we have f minus g of x. Well, that's f of x minus g of x. So again, if we have f of x is x plus 2 and g of x is 3x, we do f of x minus g of x. And simplify it all together, that would be negative 2x plus 2. Looking at a product, f times g of x would be f of x times g of x. So x plus 2 times 3x. And we'd have to distribute that throughout, so we get 3x squared plus 6x. And quotient. So if we're going to do f divided by g of x, that'd be f of x divided by g of x. And in this particular case, g of x can't be equal to 0, because then we'd be dividing by 0. So it would look like f of x divided by g of x. So x plus 2 over x plus 3 would be our total composition of functions there. Well, not composition. I shouldn't say composition. That should be our operated upon functions. So if we, again, if we're doing the arithmetic operations here. So if we have f plus g of x, and we know that f of x is 3x squared plus 7x, and g of x is 2x squared minus x minus 1. So we need to find each of these functions. F plus g of x is just going to be f of x plus our g of x. So it would be 3x squared plus 7x plus 2x squared minus x minus 1. So when we combine all these together, 3x squared and 2x squared would give us a 5x squared plus 6x, because we have 7 and negative 1, and minus 1. So this is our f plus g of x, would be this total function. So if we have f minus g of x, well, that would be f of x minus our g of x. So 3x squared plus 7x minus 2x squared minus x minus 1. So we have to distribute that negative to each piece. So essentially it would be like saying 3x squared minus 2x. So we would just have 1x squared, or just x squared. 7x minus a negative x. So minus is like positive. So this would be plus 8x. And again, minus negative 1 would be like positive, so plus 1. So this would be our f minus g of x. And the other two arithmetic function or operators, if we're doing product and quotient, again, f of x is this one, g of x is this one. So those did actually switch up. So if we want f times g of x, we'd have to do f of x times our g of x. So we'd have to do 3x squared minus 2x plus 1 times our g of x, which is x minus 4. So we would have to distribute everything here. So if we do x to each of our pieces, 3x cubed minus 2x squared plus x. And if we do this in red, I'll do it in red. 4 times each piece, or negative 4 times each piece, minus 12x squared plus 8x minus 4. Now, we'll do this in purple, combining all of our like terms. 3x cubed, our x squareds become negative 14x squared, plus 9x, and minus 4. So that is, that's our full function at the end. And this one here would be f of x divided by our g of x. Or you could write it as f of x divided by or over our g of x. So we would have to write it as 3x squared minus 2x plus 1 over x minus 4. Now, we can factor this, and it would come out to 3x, oops, I want green for this, 3x minus 1, x minus 1 on top over x minus 4. So that's what you should normally do, is look to get those factors and then cancel out. In this case, we can't cancel any factors. So either we would say this is our final answer or this one. They both say the same thing. One is factored and one is not. But both of these would be our f divided by g of x. Okay, now we're going to get into composition of functions. Now, composition of functions is we're using the input of one function stays the same, but then its output becomes the input of the other one. It's a little bit confusing, but I'll show you what I mean. Notice how here we have f of g. Kind of looks like fog. I want you to say f of g, not f times g. It is not f times g. It's f with this little o, f of g. So when we are looking for f of g, this means that we are going to start with our input of g and end with an output from f. So for f of g, we're still going to have these inputs and outputs. I think I need one more. Okay. And we're going to start with our inputs from g. So g's inputs are 7, negative 1, 4, and 8. So I would have 7, negative 1, 4, and 8. But if we look at this, when we do 7, normally just in g we would get 0. But when we look over here then, 0 gives us an output of negative 1. So we should actually have negative 1 as our output here. So f of g would actually have the point 7, negative 1, which isn't actually a point that's in either of these, but we're using the input from g and the outputs from f. So, doing that one more time, let's say we're looking at negative 1 for g, gives us an output of 7, and 7 from f gives us an output of 7. Now if we move on to 4, gives us an output of 9. 9 gives us an output, actually I'm going to do these in blue, gives us an output of 4. So 4 to 4. 8 gives us an output of 2. 2 gives us an output of 6. So this is how our f of g would end up looking. It would have these pieces in it. Now, doing the same thing, if we do g of f, that means we start with our inputs from f, and we end with our outputs with g. So again, it'll have all of these ordered pairs, just like before, and our inputs are going to be ones from the f function. I'm going to get rid of these actually. So our inputs from f are 2, 9, 7, and 0. Now, if we go to our input of 2, that outputs a 6. Now we go to g, and notice, oops, get rid of that. Notice that there are no 6s. So we would say that it is actually empty. There is nothing in this case. Now we'll try again. Get rid of that. We say that we start with an input of 9 from f, which outputs a 4. Now 4 gives us an output of 9. So this one is 9, 9. Input of 7 gives us an output of 7. Input of 7 gives us an output of 0. So we should have 7, 0 right here. And in this case, our input of 0, output of negative 1 outputs a 7. So these would be our cases. Now, technically, we have to neglect this one. This is not an actual ordered pair because it doesn't exist. It has an input, but there is no output. So that function or that part does not belong in this function. So f of g includes these pieces, or these ordered pairs, and g of f includes these ordered pairs.